So we're here with Kevin Gilman, who's the chief engineer at Lansmont. Tell us a little bit about yourself, Mr. Gilman.
Well, I'm 6'2", 220 pounds.
What's your Facebook site?
It should be 190. We can't do that. I've been working for Lansmont for 29 years now. Be 30 years coming up in 2009.
You're an old fart.
I'm an old fart. God. I've been working here longer than more than half my life now.
Yeah.
Which is either shows a total lack of motivation or it's a really good job. One of the things we have launched now is our Lansmont's own high-performance servo valve, which is...
Is that what's floating over your shoulder there?
That's what's on the computer screen here. This is
what is it now?
It's a high-performance servo valve that we use on our hydraulic vibration system.
What's the servo valve for?
The servo valve basically is the heart of a hydraulic vibration system. It directs the actuator to move in various motions that are commanded by the electronics that drive it.
So you give it a signal and it makes the table actually move.
Yeah, you give it an electronic signal from control system, and then it converts that to hydraulic flow energy, which in turn drives the actuator, which in turn moves the platform that the products are sitting on. And the reason that we need a valve like this is for many of the newer specifications that customers have for high-level, high-intensity vibration up to fairly high frequencies, up to 500 hertz.
And so what's high performance about this valve?
Well, it can produce a lot of flow at very high frequencies, and those two characteristics together make it very unusual. So that's the trick.
So this is made by Lansmont then? It's not something we buy from somebody else?
It's completely designed and manufactured by us, yeah.
Cool.
In the early days, we went out to the servo valve manufacturers and said, can you make a valve like this for us? And they said, no.
They laughed at us and sent us on our way, huh?
They said, A, it's probably can't be done, and B, if there's not $50 million a year in sales, we're not interested. So we were left in a kind of a hard position to say, well, okay, the manufacturers of these valves don't want to do it. We'll have to do it ourselves.
So we did.
We set about the task of doing it, yeah. Now we've got something that works really well.
How long did it take to go through from the we want to do this idea to the first prototype where we actually bolted it on a machine and made it go up and down?
It was about a 2-year process from concept to first prototype, and now we're about 4 years into it. So we've
so you actually started building some of these at this point.
We've got several of them out in the field now.
Cool.
Yeah.
All right.
So it's basically a fresh approach from the ground up. You know, we said if we're going to do a high performance valve, what's the best way to do it? And what we have here is the result of that.
It's kind of unique, right? It's not something that there are other high performance valves in the world, but they don't use this approach.
They don't use this approach. Yeah.
What's unique about this approach?
Well, basically, it's a direct drive valve. The concept is you've got a large flow hydraulic spool assembly that can produce a lot of flow.
I'm going to zoom in on your screen here. So, okay, go ahead.
And the idea is you drive it with a fairly high-powered voice coil assembly. So that's what we've got here is an optimized high-flow spool and sleeve assembly that's directly driven by a high-force voice coil.
So in kind of the big picture, it works kind of the way a standard servo valve works. In other words, it's kind of got a driver that's moving a spool around.
Yes.
But what's unique here is the driver is like super powerful, right?
Yes. That's the trick is we had to optimize both sides of this. Say on the left-hand side, we've got the hydraulic mechanical portion. On the right-hand side, we've got the voice coil. this voice coil driver has some unique characteristics in the fact that it can produce fairly high force, and it can do it up to high frequencies. And those two, again, are difficult to do at the same time. You can buy from a large servo valve manufacturer a voice coil type valve, but the voice coil is strictly for fairly low frequency operation. Typically they're used in paper mills or logging mills to do fairly slow motion, high force applications.
So when I hear voice coil, I'm thinking almost like an electrodynamic shaker. Is that what this really amounts to?
That's essentially what this little guy is here. This is a little ED shaker that's
mounted on a valve spool.
Mounted on a hydraulic valve spool.
Sweet!
So it's kind of a neat application. So that's basically how we did it. The traditional valves that are used in the field to do this are more complicated. They have a small hydraulic driver valve, which in turn drives a much larger spool. That's a two-stage approach.
So how does it? What's the benefit of a single stage versus a multiple stage driver?
Reliability, setup adjustments are cut in half. The simplicity of the valve, parts count, everything goes down. It's much easier to diagnose issues with the valve if there are any down the road. A two-stage valve, you don't know which stage is giving you the problem. The single-stage valve is right there. So it's easy to
either
tune.
that or it's not that.
Right, right. It's easy to tune, adjust. Everything about it is much better. So that's why we did it.
So what would you use something like this for? What kind of application would this valve be appropriate for?
It's ideal for vibration systems that need to have a lot of stroke at low frequency, and at the same time need to be able to do fairly intense vibration levels at higher frequencies, say up to 500 hertz. To cover that spectrum with a lot of flow and a lot of performance, you need a valve like this.
So for like a standard testing situation,
There are, and typically this ends up being used in cases where a customer has a fairly intense random vibration profile. We don't see it too much for sine use, but for random, some of these spectra can be quite high in the energy level. And in order to do that, you've got to have a valve that can produce that energy over a pretty wide frequency range. So this covers the bill for that.
all right. Well, thank you for sharing that with us, Mr. Gilman.
Not a problem.
Anything else you'd like to tell us about?
Can't do it on film, sorry.
All right. Thank you.